Have you ever stopped to wonder how your favorite app just knows you? How it remembers what you were looking at yesterday or what's in your shopping cart? Well, it's not magic. It's actually a really powerful language working behind the scenes. And today, we're going to pull back that curtain on SQL, the language that organizes pretty much all the data that runs our digital lives.
I mean, really think about it for a second. Your shopping cart, your social media feeds, your watch history, that is a constant, massive stream of information that has to be stored and remembered just for you. So how does it all work without just becoming a huge, jumbled mess? Well, the answer is something called a database. The best way to think of it is like a massive, super organized digital filing cabinet. Its entire job is to store everything in a very particular way so that any little piece of information can be found in the blink of an eye.
But, you can't just throw millions of files into a cabinet and hope you find them later. You need a system, a manager. And that's where a DBMS, or a database management system, comes into play. It's the real brain of the whole operation.
Here's a great way to picture it. The DBMS is like a helpful librarian. The huge library with all its books and information is the database itself. When you need something, you don't go wander the aisles yourself. You go to the librarian, the DBMS, and you ask for what you need. The librarian knows exactly where to find it and brings it right back to you. It's a really simple but incredibly powerful idea.
Okay, so not all these digital filing cabinets are set up the same way. When you get down to it, databases pretty much fall into two big families, and they each have their own unique way of structuring all that information.
And you can see the difference right away here. On the left, you've got a relational database. It organizes data into these really neat tables, kind of like a spreadsheet with rows and columns. But then on the right, you have a non-relational database, which is way more flexible. It stores data in what we call key-value pairs. Think of it like a dictionary definition. You have the word, and then you have its meaning.
So the main thing to remember is this. Relational databases, like the ones you see here, MySQL and Oracle, they're all about structure. Everything has its place. Non-relational databases like MongoDB are built for flexibility. Now, both are super useful, but for the rest of this explainer, we're going to focus on the relational ones because they are so incredibly common. So if these relational databases are like libraries with really specific rules, how do we actually communicate with them? How do we ask our librarian for what we need? Well, it turns out we need to speak a special language. And that language is SQL. It stands for Structured Query Language. This is the universal language that we use to give commands to the database. Things like adding new data, getting rid of old data, or changing something that's already there. It's the only language our super organized librarian understands. And this diagram shows that flow perfectly. Our computer sends a command, written in SQL, over to the RDBMS, that's the Relational Database Management System, our librarian. The RDBMS then takes that command and performs the action on the actual database. All right, that's enough theory. Let's actually get our hands dirty and see how SQL works in the real world. We'll start at the very beginning, creating a place to actually store our data.
The very first command you need to know is create table. With this one command, we're telling the database, hey, build me a new table and call it user. Then, right after that, we define all the columns we want, like first name, last name, email, and password. It's like we're literally drawing the blueprint for our digital filing cabinet.
And just like that, look what we have. An empty table, sure, but it's perfectly structured based on our blueprint. Each column is a nice, neat labeled slot, just waiting for us to put some data inside. So, an empty table isn't all that useful, right? The next logical step is to actually put some information in it. Let's add or insert some data. To do this, we use the insert into command. It's pretty straightforward. We tell SQL which table we're talking about, in this case user, and then we give it the values for each column, making sure they're in the right order.
And there we go. Our table now has its very first entry. We have successfully added a complete record for a user named Shai Sharma. It's that easy.
Now is a good time to just quickly lock in some key terms. Each one of those horizontal records, like the one we just added for Jai, is called a row. And each of the vertical categories, like first name or email, is called a column. Simple as that. Okay, we've created the structure, and we put data into it. Now for the most common, and honestly, the most powerful part of SQL, asking questions to get that data back out. The select command is the true workhorse here. Seriously, anytime you load a web page that shows you personalized information, your bank balance, your friends' posts, you can bet there's a select command running in the background to grab that data for you.
And look how precise it is. We aren't asking for everything about the users. We're specifically saying select first name from user. And that's exactly what SQL gives us back. Only the first names from that table. It's incredibly specific.
But what if you do want everything? Well, here's a little pro tip. Instead of typing out every single column name, you can just use select star. That little asterisk or star is a wildcard that just means all columns. It is a huge time saver.
Now, it might seem really simple, but there's actually a pretty complex process happening under the hood every time you ask for data. First, your query gets parsed, so the system understands what you want. Then, the engine optimizes it, which means it figures out the fastest, most efficient way to get your data. And finally, it executes that plan. It's a three-step dance that happens in a fraction of a second.
And what we've looked at today is really just a beginning. The true power of SQL comes when you start adding more commands. You can use where to filter for just the records you want, join to connect data from different tables, group by to summarize information, and order by to sort it all neatly. It gets really powerful really fast.
So there you have it. We've covered the absolute basics of how we create tables, insert our data, and then ask questions using SQL. This is the language that turns these massive, raw collections of data into a real source of answers. Which kind of leaves us with one final thought. Now that you know how it works, if you could ask any question of the world's data, what secrets would you want it to reveal? Thanks for tuning in.